Ooh, okay. All right, we're connecting. Okay. Ooh, that was a little bit nerve-wracking. Hey, everybody. Oh, finally I made it on. That 3 minutes really is a long time when you can't figure out how to get in. So we are live today on Facebook Live and on Instagram Live, and we're going to continue our Human Body Week. We've got two wonderful books that we're going to read and one experiment that we're going to do. So, without further ado, let's introduce our very first book, which is called Think, Think, Think. If you would like to join us and see the actual pages of the storybook, you can join us on Facebook. But if you'd like to hear the dulcet tones of my voice on Instagram, that is fine too. Hey, Oldums, thanks for joining me today. And let's get started. Okay, so we're going to talk about our brain and our lungs today and how we can use our lungs to make our brain feel good. So the first thing we're going to do is we're going to read a book about our brain. It's called Think, Think, Think. Okay, Learning About Your Brain by Pamela Hill. It's a little fuzzy there. Nettleton, maybe. Nettleton, there we go. What could you do without your brain? Nothing. Your brain is the big boss of your body. Your brain controls your thoughts, your movements, your feelings. It's like a computer that fits right between your ears. Your brain takes up the top half of your head. Your brain is soft, wrinkled, and gray. I know normally sometimes it's drawn as like a pink color, but it is kind of gray. And then on this little chalkboard it says, can you lift a jug of milk? Then you can lift an adult-sized brain. It weighs about 3 pounds. And if you're younger or you got a smaller head, it might be a little smaller. Now, contrary to popular belief, brain size relative to humans has nothing to do with intelligence. When we compare them to different species, we can look at the wrinkles in a brain to see how relatively intelligent an animal is. But if we're comparing humans, size does not matter here. So even a small brain that's only 5 years old can be really, really smart, just like a big brain that's 60 years old. Your brain is made up of 3 main parts. Each has a big job and a big name. We've got the cerebrum, which is this main part right here. And Facebook, since you already have an image, I'll just show this to Instagram. So we've got the big main part, that's the cerebrum. Then this little part, it kind of looks like an almond here. That's called the cerebellum. And then we've got the brain stem, kind of a shorter piece here. The brain stem is what connects the brain to the rest of our body through our spine. The largest part of your brain is called the cerebrum. This is the part that thinks. You use it to figure out problems at school, and you use it to make a plan for the day. Now, for any grown-ups listening, I'm just going to say that we're going to make a lot of generalizations here. So a lot of this brain science is not as simple as I'm making it sound, but for our beginning learners, I'm comfortable with making these generalizations. Your brain works even when you sleep. It helps you dream. And they say, we're not exactly sure really what dreams are yet, but most academic researchers think that your dreams are your brain trying to sort out the sensory input of the day. So what does that mean? Whatever you saw, experienced, thought about during the day, at night, it's all buffering, it's all loading. So you might dream of things that are familiar to you because you've learned about them. Sometimes our dreams don't make any sense, and sometimes we don't remember them at all. The cerebrum has 2 halves, a right half and a left half. Now, this is where in the Dr. Seuss book, they got a little into the myth of the right side of the brain being more creative and the left side of the brain being more logistical. That is not true. That's a common myth. But here it does say correctly that we've got the right half of our brain generally controls the left side of our body, and the left half of our brain controls the right side of our body. And to try this out, we've got our first experiment. So we actually have 2 experiments today. So everybody, take your hands just like this, and I'm going to take the picture book away just for a second so that you can see this. So we're going to take our hands like this, and we're going to cross them at the elbows so that our palms are facing outwards and our nails are facing towards each other. Then we're going to turn them like this, okay, and we're going to hold our hand laced. And then we're going to bring it up like this, okay? So let me do that again because I included an unnecessary instruction there. So we're going to cross our hands. We're actually going to face our palms together. Then we're going to bring them up just like this. Now, this is going to be easier if you have a friend or a sibling or a grown-up at home that can help you out. I'm just going to have to do it with my nose. So now to show you that our brain controls the opposite side of our body, I'm going to try and lift up a finger. Let's see, my hands are kind of all twisted up. So I'm going to try to lift my on my right hand, my pointer finger, okay? So when I try to do that, and I can't really think about this too much, it's actually the opposite finger that's rising. So what you'll want to do if you've got a friend, and I'm going to pretend that this is both of my hands, is your friend will point to a finger to lift up. Don't touch it though, just point to it. Then that person has to lift that finger up. And it really is a lot harder than it seems like it would be. Your brain is going to kind of confuse the sides of your hands because you've twisted them up. So now the right side of your hand is on the left side of your body, the left side of your hand is on the right side of your body. So that's a cool way to test that out. Okay, let's see what else it's got to say. Across both halves from ear to ear is the motor area. This area of the brain helps you move your muscles. You can run, jump, and sink a basket. So like we said earlier in the week, there's not just one part of the brain that does one thing. Many parts of the brain work together. But it is true that there is an area of the brain that helps us with our motor functions. And I remember what motor function is because motor makes things go. So when we move around, it's called our motor not reflexes, our motor skills. We've got fine motor skills and gross motor skills. The second part of your brain is called the cerebellum. And remember, the cerebellum is that back part of the brain, or the little brain, sometimes it's called. It's in the back of your head. The cerebellum helps you to balance. It helps you to stand, and it helps your muscles to work together. If you're an athlete, you really need your cerebellum. You couldn't walk on a balance beam or kick a soccer ball without one. So sometimes they also say that the cerebellum is the animal brain. That's where a lot of things that we don't need to think about come in, like balance. Of course, if we focus on it, we do get better, but generally when we're just walking around, we don't have to think about that. It also helps us to know when we're hungry, when we have to do natural human business. So that is the small animal brain. All right, now the book gets sideways. So turn your head with me. Let's see. The third main part of your brain is your brainstem. It connects the rest of your brain to your spinal cord. The spinal cord goes down your neck and your back. You keep breathing even when you don't think about it. That's your brainstem at work. It keeps your heart beating and your lungs working. And then the little blackboard says, your brain learns a lot during your first 6 years. During that time, your brain learns faster than any other time in your whole life. So if I have any audience members that are 6 years old or younger, now is the time to learn everything. Your brain is like a sponge. After age 6, it goes through a series of stages of pruning. Just like when we prune plants, when we kind of cut off dead ends, we're doing the same thing in our brain, but we don't have to think about it. If you learn something that you never ever used again, your brain will prune that information back to make room for more information. So the only way that we can keep our memories is by actively recounting them and using the skills associated with them. Your brain also contains many little parts that have big jobs. One part gives off chemicals that tell your body how big and tall to grow. Another helps you remember things, such as what you read in this book. Right in the middle of your brain is a sort of a thermostat called the hypothalamus. It tells you when to shiver or sweat. And a thermostat is kind of like a thermometer. Your hypothalamus is the part of your brain that keeps your body at 98 degrees Fahrenheit. So, your grown-ups might be taking your temperature to make sure that you're healthy. That's one way to tell that your body is not fighting any germs. Remember in our in our Magic School Bus book, when I can't remember what character, but when one of the characters got sick, Wanda got sick and everyone was inside Wanda and they started getting really hot because of that fever. The hypothalamus can help control that to fight off germs. Your brain has a small group of cells on each side called the amygdala. These cells control your feelings. They help you feel sad when you lose a baseball game, and they make you feel happy when you see your grandpa. So, again, this is a very much an oversimplification, but the amygdala, I believe, is actually the part of the brain that goes through both sides. And even though it is quite small, it does run through many of the other lobes in the brain, which means whenever we have an emotional memory, we tend to remember that a lot better. So if you're learning with me during quarantine and you're laughing a lot and it's silly, you might remember it more than if you were really bored and you didn't have any feelings about it. If you bump your head really hard, you might get a concussion. This brain injury happens when the brain knocks against the inside of the skull. Because remember, the brain is very soft and the skull is very hard. And even though the skull can protect our brain from all the outside things, it still is going to hurt the brain to bump up against the skull. You might lose your memory for a while, throw up, or have a bad headache. Keep your brain safe. Wear a helmet or headgear when playing rough games or when riding your bicycle. And that is really important. Doctors who work with brains are called neurologists. Neurologists. Hey, that kind of sounds like the word we learned on Monday, neurotransmitter. That's because when we see a word that starts with neuro, it means our brain. Neuroses, neurotic, neurotransmitter, neurosurgeon, all have to do with the brain. What makes your brain healthy? Getting enough sleep and eating right are helpful to your brain. Learning and asking questions are amazing for your brain. So are reading books and figuring out problems. Thinking is really good for you, so keep on using your brain. And we know that the new CDC guide on how to eat food, it's not a food pyramid anymore. It's actually a plate to show you how much of each area of food you need to be eating. It makes a little bit more sense and kind of debunks a few things that the food industry wanted us to think for a while. Okay, the brain. The three main parts of your brain are the cerebrum, the cerebellum, and the brainstem. The cerebrum helps you think, the cerebellum helps you move, and the brainstem keeps your heart and your lungs working. Again, every part of your brain is firing and working at all times. There's a rumor that you only use 10% of your brain. That is not true. You are always using 100% of your brain every single day. Now, that's not to say that maybe you'll have a memory you haven't thought of in a while, but those neurotransmitters are firing electric signals all day, every day, even in your sleep. So here's some fun activities that we can also try. Now, everybody has a dominant hand, a hand that's more comfortable to write with, and that's what we do most of our things with. I'm right-handed, which means I use my right hand more, but some people are left-handed. So something you can do to increase and strengthen your brain is do regular everyday things with your opposite hand. That's right. It might be really hard, but we know that, like, if I'm buttoning my jacket, my left hand stays still and my right hand is the one doing the buttons. Try reversing it. Try using your left hand for the buttons and your right hand to stay still. Or try making a picture with the opposite hand. See what happens. One side of your body is usually stronger than the other. Doctors don't know for sure why people end up right-handed or left-handed. And then they list tools of the trade. Doctors who treat brain problems often use a test called an EEG. It helps measure activity in the brain. Small metal discs are attached to the person's head. These discs have wires attached to them. The wires connect to a machine, and the machine reads patterns of activity in the brain. Then the machine prints those results on a sheet of paper for the doctors to read. A doctor might also use these tests, other tests besides an EEG, like an MRI or a CT scan, which is also called a CAT scan, even though it's not for cats. And they can use computers to take pictures of your brain. And look at that, you know I love a good glossary. It defines some of the words that we already went over, like cerebellum, cerebrum, concussion, neurologist, all of those awesome words. So excellent, we just learned a little bit about the brain. Now, one thing that the book didn't talk about was our emotions. Well, it talked a little bit about the emotions. Sometimes it feels like we can't control our emotions. And especially when we're here in quarantine, things can get frustrating. I don't know about you, but I like to challenge myself by doing puzzles, games, things like that. Have you ever gotten really, really frustrated when you can't find that missing piece of the puzzle and then you just swipe it all away and you ruin it for everyone else? Well, instead of ruining it for everyone else, we can learn how to take deep breaths. And those deep breaths can help us focus and recenter. Because when we're frustrated, sometimes what we need is to step away from the problem and come back. So let's learn a little bit about our lungs. And it looks like we have another friend that just joined us, Armand. Hey, thanks for joining us today. If anyone has any questions about the brain or the lungs or just anything they're curious about, feel free to write it in the comments. Okay, so our next book is Breathe In, Breathe Out. And after we're done the book, we're going to try an experiment. I tried to start it before our story time, and it's not really working the way it should. So we're going to work together to use the scientific method to see if we can't fix it. So next up, breathe in, breathe out, learning about your lungs. Take a deep breath. Have you ever thought about where air goes once it's inside your body? So everyone, let's take a deep breath through your nose and then out through your mouth. See if you can trace where it's going. So it goes in, it goes down that air tube, it goes into your lungs fill up, and the oxygen from our breath can help go to our bloodstream, and then the air comes back out and we exhale it. The air you breathe goes into your lungs. They're sort of like two pink balloons. And I don't have pink balloons, but I do have two balloons like this. Your lungs fill up with air when you breathe in, and they send out air when you breathe out. You breathe about 20 times every minute when you're resting. So if these are our lungs, it's kind of a little bit more complicated than just a regular balloon. If you're looking at the storybook, you can see that there's a lot of branches. So those branches would be inside the balloon, and when you breathe in, those branches inflate, and when you breathe out, they deflate. So this would be our lungs after we breathe out. Your lungs are in your chest, and your rib cage protects them. That's a good thing. So if you feel your chest, you feel those little bumps right here. All of those bumps are bones that are protecting your lungs. So your lungs are actually inside of those bones. Just like our skull protects our brain, our ribs protect our lungs. So here's the experiment that I tried to start. And this is just representing one lung. So we know that we have two, but since I live by myself, I do not have any big soda bottles. I only have these small ones. So our diaphragm helps our lungs to breathe. And our diaphragm is represented underneath here. Then this will be one branch of our lung inside. And we'll get to more of that experiment in a little bit. Your lungs are very important. Lungs bring a gas called oxygen into your body. You need this gas to live. And remember, oxygen is found in the air all around us, but it's actually a really small part of the air. So actually, I'm going to use my whiteboard, which I haven't really taken too much advantage of. So let me shut off the storybook for a minute and I'll turn it back on. There we go. If our air is 100%, so everything that we breathe in, and let's see if I can get Instagram to look at this too, okay? Then about 78% of the air, so I'm just going to start by making some guides here. So I know that each one is 25, 50, 75, so it's a little bit more than 75. We'll say like right there. So all of this space in our air is something called nitrogen. And nitrogen, even though it's a big part of the air, it's not what we need to survive. So this is nitrogen. Then we have another part of the air that makes up about half of 1%. So it would probably be even smaller than that sliver. And that would be our carbon dioxide, CO2. And then what we need, that oxygen, is just this green part right here. And that's shortened by the letter O. Nitrogen, the letter N. So oxygen is what we need so much to survive, and our lungs can take just the oxygen out of the air, which is pretty cool. And it just takes exactly what it needs and nothing else. So, that always scares me. Okay, let's see here. Which one just fell? Oh boy, out of control. Okay. All right. Okay, so let's bring back the book. Here we go. Okay, so we see that oxygen and gas is all around us, and our lungs can take it and give it to the rest of our blood. And now I just realized that I might be able to rotate this whole thing. Nope, I can only make it bigger or smaller. Okay, so now let's turn our head sideways again so we can read this, and it says, whoosh, air enters your body through your nose or mouth. Your throat collects the air and passes it to a tube called the windpipe or the trachea. The windpipe splits into two tubes. Each tube leads to one of your lungs. So that's why I just made one tube to one lung. And then you can almost imagine that there's a whole another one for the other part of your lung. And isn't it interesting that a lot of the parts of our body has two parts to it? Remember, our brain is on the right and the left. Our lungs are on the right and the left. Our heart is separated into different ventricles, although that's more like 4 parts. But lots of our body parts work together in teams in order to work. Inside your lungs, there are soft little tubes called bronchial tubes, and air moves through these tubes. The bronchial tubes have a sticky liquid called mucus in them. Mucus is also known as your boogers. Mucus catches dust, germs, and other things. You can get rid of these things when you cough, clear your throat, swallow, and sneeze. Chew. But especially now, we always do a vampire cough. We're covering our mouth so we can keep our bodily fluids, our mucus, to ourselves. The smallest section of your bronchial tubes are called the bronchioles. If you were to draw them, they would look a little bit like the branches of a tree. At the end of the bronchioles are lots of little air sacs or bubbles. These air sacs are called the alveoli. The alveoli are the final stop for your air. Your blood passes back and forth through the walls of the alveoli. The blood picks up fresh oxygen from the air you breathe and drops off carbon dioxide. Your body doesn't need carbon dioxide, so you get rid of it by breathing out. Then your blood rushes to all your body parts, bringing oxygen and energy. When blood is filled with carbon dioxide, it is blush purple. When it has fresh oxygen, it is bright red. I'm not sure about that one. I don't feel super confident about it, but I'm going to have to do some research on that. When you breathe, a special muscle called the diaphragm moves underneath your lungs. It helps push air out and pull air in. Take a deep breath and feel your diaphragm move down. It gives your lungs lots of room. So breathe in through your nose. And when you do that, if you put your hand right about here, right above your belly button, you'll be able to feel your diaphragm. Lungs love exercise. Run hard and feel how your lungs change the speed of your breathing to help you. Blow air back out again. You can feel your diaphragm bounce back up. So let's do that again. So when we breathe out, we feel our belly going out too. That's our diaphragm giving our lungs more room again, and it gives it less room when we're breathing. Some people have asthma. Asthma is a disease that makes it hard to breathe. Playing or working hard can make asthma worse. Cold weather can also make it worse. People with asthma may carry inhalers. Inhalers bring medicine to their lungs to help them breathe better. And asthma is, it means that those branches that we saw in our lungs are already not clear and open. So they're maybe smaller or blocked off, and we can't use as much of our lungs as everybody else. Has anyone ever told you to take a deep breath? Maybe that person was trying to make you feel better. Maybe he or she was just trying to help you calm down. Taking a deep breath helps give your body the fresh oxygen it needs, so breathe. The worst thing you can do to your lungs is smoke. Smoking makes it hard to breathe. Smoking can cause cancer in your lungs, so don't smoke. And then this shows a nice image of the bronchial tubes, the windpipe, the bronchioles, and the alveoles. Now, let's see. They say, take a deep breath. Do the following test. Then compare your answers with a friend. So we'll try this. Then we'll see if there's anything else worth looking at the other pages. Then we'll look at my lung experiment. Okay. Count how many breaths it takes for you to fill a balloon, and count how many, okay, so that's number 1. Number 2, count how many seconds you can hold your breath. Number 3, count how many breaths you can take in 1 minute when resting. And number 4, run in place for 2 minutes, then count how many breaths you take in 1 minute. So let's try this together. I'm going to try to blow up my balloon here, and I'm going to stretch it out just to make it a little bit easier. And we're going to see how many full Britney asthma breaths it takes to fill up this balloon. So, before you do any kind of like holding your breath or anything, you want to make sure to take a few good deep breaths first. 1, 2, I think I can do it in 3. That's about 3 breaths to get a full balloon. Okay, now I'll let you hold your breath when we're all done. And then when you're going to sleep tonight, I want you to try something. When you're really calm and you're in your bed and you're breathing nice and slowly because you're resting, with your eyes closed, I want you to try and count your breaths. 1, 2. That can sometimes help you go to sleep, like counting sheep. Okay, and it just has a glossary for us. So let's see. When you go to the doctor, they listen to your lungs. Your doctor uses a special instrument called a stethoscope. This tool makes the tiny sounds inside your lungs sound loud. The doctor puts the stethoscope's flat disc on your skin. Then they listen to your heart, your lungs, and other important body parts. These sounds tell a doctor a lot about what's going on inside of you. With the help of a stethoscope, a doctor can tell the difference between healthy and sick sounds. That's another experiment that I really wanted to try today, but I don't have the right materials for it. But if you have a funnel and a balloon and some tubing, you can make your own stethoscope. So let's see here. Weird. Okay. I see Kira and Lainey are having fun with some emojis. Love that. Okay, so let me show you the experiment that I tried to do, and I'll tell you what my problem is. So where is my... Here we go. Oops. I'm just trying to get my scientific method out. Looks like I crushed it a little bit. Okay, so our scientific method, we can do lots of things, not just science experiments, but we can think through our problems using the scientific method. And we always start with an observation. So your observation was that Be the Scientist posted this science experiment for you to try at home. And your question is, can I do this with my household objects? Well, let's find out. Can we make a lung model out of balloons, a bottle, some straws, and tape? I think we can. My hypothesis was yes. And when I tried my experiment, the experiment didn't work. So I'll show you how I did it. I have a soda bottle and I cut the bottom 2 inches off with some scissors. So this is the bottom, and I cut it off with some scissors. Then I took a straw and I used this as the tubing. So I took the straw, I put it inside the balloon, and then I put a rubber band around the top, and then I taped it. And you can see the tape on the inside of the bottle there. So that is the bronchioles, right? The tube that goes down into your lungs. And then within the balloon would be all of the stems and all of that. Then this part is supposed to be your diaphragm. So at the very bottom, we cut a balloon, and what's supposed to happen is I'm supposed to be able to pull on this, and it's supposed to make my lungs contract. And then when I push it back open, it's supposed to open up again. But as you can see, as I'm doing this, nothing's really happening. So I'm going to pull the instructions back up again, because if I ever get confused, that's a really good way to see if you missed anything. And sometimes I get a little excited and I tend to skip some steps. So you can find the instructions on www.facebook.com/BeTheScientist under posts. And I'm just navigating there now. And my computer's a little slow because I'm talking to all of you guys. Hey, Alec, thank you so much for joining us. Another friend from work, ex-work, that's weird to say. Okay. All right, so how to make a model of the lungs by ThoughtCo. Personally, I might try to find a website with some better images, because this one only has one picture and it's not very helpful. So here's, it says gather together the materials listed. Then fit the plastic tubing into one of the openings of the hose connector. Now, instead of using that hose connector to make 2 lungs, I just made 1, so we can skip that. Place a balloon around each of the remaining 2 openings. Okay, so that's what I did here. I put the balloon over the straw. Then tightly wrap rubber bands around the balloons where the balloon and the hose connect. Check. Measure 2 inches from the bottom and cut it off. Check. Did that. Then place the balloons and the hose connector inside of the bottle, threading the plastic tubing through the neck. So I did that. I took the straw. I don't know if you can see it here. I took the straw and I sealed the bottle on top of the straw, and then I just cut it off so you can see it a little bit right there. So what I did is I let the straw stick out, I sealed the top, and then I taped around it. And when I do this, I don't hear any air leaking. I did before. So if you want to see if there's any air leaking, you can use your sense of, you can listen to it and see if that works. Okay, so tie a knot at the end of the remaining balloon and cut the large part of the balloon in half horizontally. So that's cutting the top part of the balloon off, so you just have the bottom with the tie. Check. Using the balloon half with the knot, stretch the open end over the bottom of the bottle. Gently pull down on the balloon from the knot. This should cause air to flow into the balloons in your model. Doesn't do it. So what I'm wondering is, maybe I needed to start with no air in my balloon. Maybe there's air stuck in there and that's kind of affecting it. Now, the idea here is it's not just your breath that helps you breathe, but it's the pressure from your diaphragm that helps you breathe as well. So, for the rest of the day today, I'm going to try to get this experiment just right, and then I'll post a video or I'll go live again today to show you my solution. Now, remember, if you're getting frustrated, take a deep breath, and then another deep breath, step away from it, and then come back. So, we got to my analysis. I did my experiment, which is the green arrow. The experiment was trying to make it. My analysis is that the diaphragm doesn't seem to be affecting the lungs. And my conclusion is I must have gone wrong somewhere. So my observation is maybe I can find another set of instructions that might help me out a little bit more. And I'm going to send you that if I find a good one. So, before we end today, I want to take a few deep breaths with you. So let's take 3 deep breaths in through our nose and out through our mouth, and it'll help us relax, and then we'll sing the goodbye song, okay? We're going to spread that oxygen all throughout our body, including in our blood and in our toes. So, sit nice and comfortably wherever you are, or stand and take a deep breath in through your nose. Now wiggle your toes and take a deep breath out. Okay, take another deep breath in through your nose and wiggle your nose and take a deep breath out. Okay, take a deep breath in through your nose and wiggle your fingers and take a deep breath out. Okay, now it's time to say goodbye, but before we sing our goodbye song, thank you so much for tuning in today. We've been getting a lot of viewers that come and watch my videos after we're live, and I want to thank you if you tuned in and we're not here anymore. Now, not expected, but totally appreciated. You can donate to my Venmo or my PayPal account, paypal.me/BeTheScientist if you're on Instagram, and Venmo Brittany Wickham. It is, again, not expected at all. I'm doing this for you and your kids, but this laid-off educator could certainly use a little bit of kindness. So, if you liked what you saw, if you learned something new, feel free to donate. If not, also, you can check out my website, www.BeTheScientist.com, and my Linktree, Linktree/BEE the Scientist, where you can find some of my favorite videos, my YouTube page, all the other resources that I'm making available. And without further ado, it's time for the goodbye song. Oh, wait, first I just wanted to show you this very Philly specific pin. Since it's Human Body Week, I have a body that's not so human of Gritty, and his bones are made of cheesesteaks. Ah! Okay. So long, farewell to you, my friend. Goodbye for now. Until we meet again. So long, farewell to you, my friend. Goodbye for now. Until we meet again. It's been great to play and read together in the hive, but now it's time to say goodbye. So long, farewell to you, my friends. Goodbye for now, Until we meet again. Bye, everybody. See you on Friday at 2 p.m. Eastern Standard Time. So long.